Hello, welcome to Business Statistics. In this lecture, I will talk about paired difference. Suppose we wanted to measure the wear and tear of two shoe companies, Reebok and Nike, and we are interested in comparing the wear and tear in the shoes of Reebok and Nike. So based on our previous experience or previous discussions, one of the ways we can do it is we can take a sample. This is sample 1. From a population. Say 10 people. And then take sample 2 from a population. So this is also 10 people. Let me draw maybe a population like this. So this would be the population. So this is the population. And the thing is, we can ask these 10 people to wear Reebok shoes. And these 10 people to wear Nike shoes for 1 year. So we can ask them to wear Reebok and Nike shoes for 1 year, and after 1 year we can take the shoes back and measure the wear and tear. So that's one way of setting up an experiment, but the problem with setting up experiment in this way is different people walk different distances. So a person who walks a larger distance will have larger wear and tear, and a person walking shorter distance will have smaller wear and tear. So it's not a good way to set up an experiment, because if all the Reebok people who wear Reebok shoe walk longer distances, then the experiment becomes biased. So to avoid this problem, what we do is we take each observation. Suppose if we have an observation 1, so when I say observation 1 or each observation, it means this is person 1. And this would be leg 1. So, and this would be leg 2. So what we can do is we can ask each person to wear Reebok on one leg and Nike on the other leg. So what this does is if a person 1 travels certain distance, the shoes Reebok and Nike are traveling the same distance, so the wear and tear should be same. So we are bringing both of them as a pair to one observation such that we can properly gauge the wear and tear. So we can do the same thing with observation 2. So this will be person 2. For our convenience, I am writing person 2. So on until observation n. So this is person n. So now if we get a measurement for observation 1 as x11, so here the first one represents the observation number, that is person 1 or observation 1, and the second one represents the leg. So that's how you write x11, and then that means for the first observation x1, leg 2 is represented by x12. So similarly, observation 2 we will have x21, and here we will have x22. So in fact these are at this time we define them as variables. All these we are defining them as variables, but when we solve problems those will be numbers. So on up to x n1, and this will be x n2. So now we are trying to compare, so we are trying to find the difference between the wear and tear. So we will have the difference. So we are trying to compare between Reebok and Nike, so that's the difference in the wear and tear, which is represented by small d. So now the difference can be, in this case I will take Reebok minus Nike. However, we can also take the difference as d as Nike minus Reebok. So it is very important how you define your difference. It's really important. So do you take Nike minus Reebok or Reebok minus Nike, because the values will change. It will turn into positive values, might turn into negative for the other case. So here the difference would be d1. I will define it as d1 for the first observation or first person, which is x11 minus x12. So D2 would be x 21 minus x 22. Dn would be x n1 minus x n2. So if you see, we have converted by pairing them. So we paired Reebok and Nike and converted these two variables into a single variable, which is d1, d2 and dn. So now I would be interested in knowing the mean difference. So that is given by so the mean difference is given by xd bar, that is equal to d1 plus d2 so on until dn divided by n. So this is the mean of the differences. So one of the assumptions which we will make here is these differences follow a normal distribution. So by making this assumption, we will now have a standard deviation of the difference. So this d here represents the difference. So it's just a way to say that we are dealing with paired difference. So now the standard deviation of the difference, SD, again here d represents the difference, just paired difference, that is why we are specifying it. It is equal to square root of summation of, so this will be similar to our standard deviation which we learned previously for one sample. So di minus xd bar whole square divided by nd minus 1. So again here n minus 1 was our previous, when we were tackling one sample, it was n minus 1. The d represents the difference, the paired difference. So that would be our formula for standard deviation of the difference. So now that we know the concept, we will talk about hypothesis testing and confidence interval for paired difference. So hypothesis testing So the first step of hypothesis testing is to define hypothesis. So in our case, in paired difference, the important thing is you have to define your difference first, which is are you doing sample 1 minus sample 2, or are you doing D is equal to sample 2 minus sample 1. So this is the difference. This is very important to define because your values will change based on how you choose. So once you do that, now you have to define your null hypothesis. So this is given by mu d. Again, we are representing this d for paired difference. So this is equal to 0. Alternative would be mu d not equal to 0. So as you know, this is a two-tailed test because we can test on both sides. Again, we have H null, mu d greater than or equal to 0, and the alternative for this would be mu d less than 0. So the third case would be H null, mu d less than or equal to 0, and then the alternative would be mu d greater than or equal to greater than 0. So these two are one-tailed test because we can test it only on one side. So once we define our hypothesis, the next step would be to compare the test statistic with critical value. So test statistics, usually for paired difference, the sample sizes are small. Since we converted a 2 variable into one variable, we have only nd, which is the sample size, should be less than 30. So usually they are small samples for paired difference, so we can use t-stat. So the formula for t-stat will be xt bar minus mu d divided by st over square root of nd. So again, this is the mean. So this is the mean of the sample difference. Sample mean of the difference. And this is the population mean of the difference. This is the standard deviation of the difference. So once we have this, we will compare it with the critical value. So as you know, for one sample t stat, when you did it, the critical value would be t alpha over 2 and the degree of freedom. So this is for two tail, because we have alpha over 2. Then for one tail it would be T alpha degree of freedom. One tail. So the degree of freedom in both the cases, will be ND minus 1. So that is how that is what you will use from our statistical table, and then finally you make conclusion. So now that we know how to do hypothesis testing, we will also set up our formula for 1 minus alpha confidence interval. So 1 minus alpha multiplied by 100% confidence interval. So alpha here is a significance level. So the formula for this would be xd bar plus or minus T alpha over 2 degree of freedom SD over square root of ND. So the degree of freedom here is ND minus 1. So if you see this formula, XD bar is the estimator, and then this is the margin of error. So this is how we will be kind of doing hypothesis testing and confidence interval. So now that we know the concept of paired mean, both hypothesis testing and confidence interval. We will try to solve a problem in this. So again, I will take the same example of Reebok and Nike. And I wanted to measure the wear and tear. So I claim that Reebok has less wear and tear. Compared to Nike. So I wanted to do the hypothesis testing at 95% confidence interval. So now we do an experiment. So this is all will be given. So I have person 1 so this is leg 1. So this might be right leg or left leg, that is not important. So this is leg 2. We can randomly select leg for to wear Reebok or Nike. And then we ask, suppose for one leg the person wears Reebok, on the other leg the person wears Nike. So this is random, it's not like leg 1 can be both right and left leg 2 can be both right and left leg, any one of those. So, and we will measure the wear and tear of both the shoes in millimeters. So this is millimeters. So we have person 1, suppose we have person 2, person 3, person 4, person 5. So the measurements, we after 1 year they wear Reebok and Nike, and we get the following wear and tear. So for Reebok, for person 1 it would be 2, for person 2 it's 3, 1, 2, 3, 4 5 2 3 1. So once this entire data will be given to you, so all this data will be given to you when you solve problems. So now I will calculate the difference. So the difference is defined by D. So now it is important to do the difference, whether it's Reebok minus Nike or Nike minus Reebok. That is very important. So let's do, for our case, Reebok minus Nike. So I will write Reebok as R minus N. So Reebok I am representing by R and Nike I am representing by N. So the difference D1 is equal to 2 minus 3, that is negative 1. D2 is 1 minus 2, that is negative 1. D3 is 3 minus 4, that is negative 1. And then D4 is 5 minus 2, that is 3. D5 is 3 minus 1, that is 2. So now I am interested in calculating the mean of the difference, which is xd bar. So I will calculate xd bar, so which is the average of all the deviations. So that is, the formula is d1 plus d2 so on until dn divided by n. So here we have 5, so d1 is negative 1, d2 is negative 1, so I will do minus 1, d3 is also negative 1, plus 3 plus 2 divided by n is 5. So this is going to give us 2 divided by 5.4. So the next step would be to calculate the standard deviation, which is given by square root of summation of di minus this is xd bar. Let me erase this. So this is xd bar whole square divided by nd minus 1. So the sd would be square root of, so this is minus 1 minus xd bar is 0.4, so I will do 0.4 whole square plus negative 1 minus 0.4 squared plus minus 1 minus 0.4 whole squared plus, again I have 3 minus 0.4 whole squared. So I did this plus 2 minus 0.4 whole squared divided by nd is 5, so we have 5%, that's 5 observations, 5 minus 1. So this is going to give us, if you calculate this, it's going to be 1.9493. So once you get this, for hypothesis testing, the first step of hypothesis testing is to define hypothesis. So I will define my hypothesis here. So H null. So now I am saying Reebok has less wear and tear. So I am saying it has less wear and tear compared to Nike. So my alternative, H alternative, would be mu D. So D is Reebok minus Nike, should be less than 0. That means my null hypothesis would be mu D greater than or equal to 0. So the next step would be to compare test statistic so this is test with critical value. So our test statistics formula is T is equal to, because we have only 5 samples, we will be using T stat xd bar minus mu D divided by SD by square root of ND. So xd bar is 0.4 so this is 0.4 minus, now mu D is the hypothesized difference, so the hypothesized difference value is 0, divided by SD is 1.9493 divided by ND is 5, so that is square root of 5. So the T value which we will get if we calculate this, is 0.4588. So the critical value, to obtain critical value, we have to go to our T table. So the critical value, so now we have this is a one-tail test, because we have greater than or equal to, we can only check on one side. So we have T alpha ND minus 1 would be our degree of freedom. So alpha, we have 95% confidence interval, so alpha would be 0.05, and so that is T 0.05, and then ND minus 1, ND is 5 minus 1 is 4. So we have to look in our T stat table the value T 0.05 and 4. So one of the first thing I would do is I would draw our what's that, mu d curve, which represents the normal curve, because we made an assumption that all the differences will behave normal. So mu d, so because we have mu d greater than or equal to 0, that means we will have a lower bound for mu d. So this is the lower bound, suppose. So this would be, as you know, maybe I will try to explain. As you know, the T table gives you always the right side of the curve. So this is T alpha degree of freedom. So to get the left side of the curve, you can do negative T alpha degree of freedom. So here we will have negative T 0.05 and 4. So anything above this curve, don't reject H null, don't reject H null. Anything to the left of this curve, of this line, critical value, is reject H null. So now let's go to our T table and look for T 0.05 and 4. So I will go to the T table. So here is our T table, and we are looking for T 0.05. So that is this one, this row, and 4 is this row. So T 0.05 column and 4 row, that is this value. So let me highlight it with the green color. So that is 2.1318. So I will go back to our sheet. So this is the critical value would be this value would be 2.1318. So now I would look at the T stat value and try to ask where does it lie on the number line. So if you see, T 0.458 lies to the right of this critical value, so it lies in the don't reject region. So that means don't reject H null. That means our null hypothesis is true. So that means my claim Reebok has less, because I used Reebok first and Nike second. Reebok has less wear and tear is a wrong statement. So this is not, there is not sufficient evidence to prove this. So this is not true, or we don't have any. The main thing is we don't have evidence to prove that. So that's how you solve hypothesis testing. Now I will discuss confidence interval for a two tails. So this is a two tail confidence interval. Two tail confidence interval for paired difference. So if I wanted to calculate 95% confidence interval for the same problem which we discussed, so the confidence interval formula is xd bar plus or minus T alpha over 2. Because it's a two tail, we will use T alpha over 2 nd minus 1 st over nd. So we calculated all these values. So if you see, this is 0.4, this is 1.9493, this is 5, and this one we last time calculated, because it's a one tail, we calculated T alpha and d minus 1. Now we will do T alpha over 2. So if I have 95% confidence, that means 1 minus alpha is equal to 0.95. So alpha is 0.05, alpha over 2 is 0.025. So now I am looking for T 0.025 nd minus 1, nd is 5, 5 minus 1 is 4 in our previous problem. So I'm looking for T 0.025 comma 4 value. So I will go to my sheet again and look for what is T 0.025 and 4. So T 0.025 is this row, this column, and 4 would be this row. So that is the value will be 2.7764. So this is would be 2.7764. So now our 95% confidence interval would be 0.4 plus or minus 2.7764 multiplied by 1.949359 maybe divided by, so 9493, let's leave it at 4 decimals. Let me erase this. divided by square root of 5. So if you open up this interval, it would be 0.4 minus 2.7764 multiplied by 1.9493 divided by square root of 5 comma 0.4 plus 2.7764 multiplied by 1.9493 divided by square root of 5. So this is going to give us negative 2.02 comma 2.82. So what this is saying is, if you see mu d, so I have d is mostly Reebok minus Nike. So the difference of Reebok minus Nike would lie between negative 2.02 and positive 2.82. So that means we have 0 in this confidence interval. So that means both Reebok and Nike might be should be equal. So they have equal wear and tear because we have 0 in that limit. So we can say that Reebok and Nike both have same kind of wear and tear. So this ends my lecture on pair difference. Thank you.